Hey, hello, and welcome to the show. It is me, John Park, and it is time for JP's product pick of the week. Thank you so much for coming on this right before Thanksgiving edition. Happy Thanksgiving if you celebrate that. Gobble, gobble. And, well, let's see. What else is going on here? I've entered the realm of e-ink, and I think I'll end that right there. Oh my gosh. Hey, look, it's full color now. So I have got some people over in the chats that I want to say hello to. Tackle the World and Dave Odessa and Ken Piper over in our YouTube. Thanks for jumping in the chat. If you're wondering where the other chat is at, that's it right there. You can go to adafruit.it/Discord. That will take you right to our Discord server, and then you can look for that channel right there. That's the live broadcast chat channel. And hello there to Thin Man, Sam J. Ohio, Tyrone, Byron, hello. Hey, C. Grover. Hey, John Nodge. Thanks for jumping in. I see Dave W09NY was typing, so hello. I'll say hello to you, although the message disappeared. And yes, what is going on here? I've got a cool product pick, and I want to direct you to it by going over to that URL right there. It's product number 5727. You can go to the QR code, or you can use the URL there. This show, as always, is broadcast from inside of that page. So you can go over there, watch the show inside the page. Be poised if you're convinced that it's something you can't do without, or at least think is neat and would like. You can buy it, and you can buy it at a deep, deep discount because it's 50% off. We were able to stash just 50 of them before the show. We usually strive for 100, but there were not as many available on this one, so we have 50. Go check it out. It is actually 10 maximum per customer, depending on your plans. You could go wild. No resellers allowed, no coupon code necessary, and no rain checks. So the price is good while the price is good. It'll go back up after the show. And if they sell out before you buy it, we don't have any recourse for that. So this one, I think I was for some reason I was unable to find this on the Ask an Engineer new segment. It may exist. It just wasn't the video linked in our product page. But I instead put together, I added a little bit of ToddBot music. Thanks, ToddBot, for allowing me to use this, for suggesting some tunes for this. And I just have a 40 or so second long demo video I want to show you, and then we'll get on with it. So check it out. Yes, indeed. Thank you so much, Todd, for that. And I'll put a link over in the Discord, and how about the YouTube as well, to a playlist that Todd shared with me, which was Jamuary last year. There's a tradition in various musician circles in January to try to do a song a day or a jam a day. So that was one from day 25, I think it was. So go check those out. I think they're pretty cool. So what is this? Let me grab the one that I have that's not actually plugged in. It's actually still in the bag. So I'm going to open that up dangerously and tell you all about this. So that right there is my product pick of the week this week. It is the Adafruit Feather RP2040 ThinkInk for 24-pin e-paper displays with Stemma QT. And in fact, I'll bring up my little Chiron, which I should have had up because then I could just read that off of there and try to remember it. So there's the price. There's the stock count. That'll change. This is queried every 15 seconds using a fruit jam. This right here, it's a feather. It's the same as a Feather RP2040 in most regards. It has STEMMA QT out. It has USB-C. It has battery charging, LiPo charging built on board. Lots of GPIO. Stats-wise, I had written these down. It is 8 megs of SPI flash. It has 264K of RAM. It's a RP2040, so it's the Cortex M0, dual Cortex M0. And this one has our little 24-pin flex cable connector on there that you can use to hook it up to drive e-ink displays or e-paper displays. So let's bring up this page here for a moment, and you can see it. We are selling them for $8.75 during the show. And you can see some nice images. I'll show you some others of those in a moment. Nice images of the board itself, but more importantly, here's the board plugged into some e-paper displays. This is a 7-color display. There are grayscale displays, black and white monochrome displays, tricolor displays, quad-color displays. Those will all work with this if they have that 24-pin flex connector. There's a good chance they work. We sell a bunch of different ones, so if you scroll down in our page, you'll see a bunch of raw e-paper displays. That's what you use, and there's more info about that in the guide. So if I click on this link right here, primary guide, you can see, here's the refresh on one of those 7-color displays, which takes a while. So this type of display is sometimes called like a label display, used for putting labels on shelves in grocery stores, that sort of thing. So it's a little different than the type of display you'll find in a Kindle as far as they don't refresh quite that fast. But these can do really beautiful display with however many colors that display supports, including these new 7-color displays. It may take a while to get the image up there. As you can see here, it's refreshing each of those different color layers. But then once it's up, it's up. You can, in fact, even remove power, take it off of the feather if you want. It's going to remain static. So here's the display with its little 24-pin EPD, e-paper display connector at the bottom. And if we scroll to the next page, you'll see we've got the pinout listed here. Connections, all the usual expected connections from a feather. Lots of analog pins, lots of digital pins. So really useful if you're doing things where you want to be able to use maybe a STEMMA QT sensor or something like that for an input, have battery power, keep it mobile, and then change the display every once in a while based on some data that's coming in. This would be perfect for that. Does not have the kind of horsepower that the one I showed last week, which is running off of a full-blown Raspberry Pi single-board computer. And here we're pumping frames from a full 2-gigabyte movie. You're not going to do that with this type of display, but this is much cheaper, or this type of microcontroller much cheaper, much simpler. You can run your displays using the different libraries that we have for all the different chipsets on these common displays through CircuitPython and Arduino. We have, if you take a look at this CircuitPython Essentials and Arduino IDE example, we've got e-ink examples, that's for most of the displays, and then these 7-color ACEP examples, which are a little bit different. So let me show one. Let me drop to this downshooter. Here you can see I've got, let's see, does this even say, I don't know how to, if I can read that to see what size this, I can't remember what size this one was, 5 point something? I think it's a 5.3 inch or something like that. So this is a monochrome display I have on here running CircuitPython. If I plug this in, as you can see right now, it is, where did my, oh, I stole, I stole a cable. Let's see. Here's a likely one. Yeah, hold on. I'm going to swap out. We're going to lose the, I was using the wrong cable, so I got to do a little switcheroo here. All right, so I'll plug this into my computer over USB-C. And when this starts up, you'll probably see it go through the refresh. And you can see with the very few layers of a monochrome, it's a lot quicker versus something like that 7-color display. So here is one of our standard BMP files that we like to test things on. This little ruler shows us, in this case, it's 416 pixels by 240 pixels is what this display here is. I have this set so that it will update after the sort of factory suggested refresh. You can do things to cheat, but you'll get the longest life out of these if you respect that. Let's be a little disrespectful for a moment, and I'm going to open up my IDE here. And let me open up the code.py. This is an example that's running in CircuitPython. So I'll open up the code.py on that board. Sorry, 3.7 inch, is that right? Yeah, maybe that's right. Maybe it's 3.7 inch, 240 by 416. And I'm gonna go and just change out, even though this will refresh after a minute or so, I'm gonna just be impatient and change the image out. I just have one big image that I'm sliding around, so I'm gonna save that. And now it's gonna, when this refreshes, it's going to show a different section of this, kind of like a tile map. So here you can see I've got some neat little 1-bit artwork from a video game. There's actually some video game assets from itch.io. And if I go to full screen there, you can see it a little bit better. So really nice, really fun to be able to update these kinds of displays using CircuitPython. The other example that I have here, I'll move this out of the way, is with a big tricolor 7.5 inch display, and I have an extension cable on there. But if I can get that glare off of there, let me prop this up for a moment. Oh, I introduced a new glare. Okay, I'll use my hand to hide that one. So here you can see I've added a whole bunch of red to that image and some dithered patterns so that you can see the tricolor in effect. Get closer and goose the exposure a little bit. Just focus. So love these tricolor displays, and it is really great to be able to just use simple code in CircuitPython display IO to throw a BMP image up there, or you can do text, you can do different graphic shapes, that type of stuff on here. So if we take a look back at, let me go back into, and I'll expand the scale of this a bit now. Put this other image back here. So you'll see here, this is running over SPI. So one of the first things that we do, other than importing the specific, the chip specific for that display library, in this case UC8253 is the one for this monitor. All of our displays that we sell will let you know in the Learn Guide or even on the product page which chip is used, because they vary a lot. So we import that library, which contains all of the specifics about timing and memory and messages. And then I'm also using display IO, so I can release displays, use SPI, and then specify the SPI pins that are over this 24-pin display here, and then create the display itself. So UC8253 over the display bus, width and height, which pin we're using for the busy pin, rotation. Some displays you can do 90-degree increments, some just 180 seems to work best. In fact, this will probably make a mess because of my, I'll go ahead and save this though. Because this is sort of a tile map, when this rotates we may just see mostly white from one corner of the display. Oh no, okay. That worked better than expected actually. I guess it just changed the origin point and the rest of my code is working. Hey. Nice happy accident. And then I have some timings here for how long to try to refresh. This one didn't work in this case, so I'm not using that. Using some transposition to move it around, translating on X and Y to move it around. And then this is the key right here, this display.time to refresh. that will allow it to use the sort of correct, and this is in our sample code for most of these examples, the correct per the factory for that display so you don't burn the thing out. So the code is pretty simple. You can check that out in most of the guides. If we take a look back here, oh, sorry, way out of focus. Back in focus. Let's get a little closer on this one. There we go. I'll flip that back around and resave. So you'll see it go through its little reboot and refresh dance there. I like how it always shows the inverted image at first. As Todd just said over in the chat, you don't need power for these. So once that image is there, you can remove power from the feather, or you could remove the display from the feather's display connector there just by popping that out and pulling that off. I won't do that right now because that's a bit of a pain. But yeah, it's just going to look like that. These also, by the way, look kind of neat from the reverse. Don't know how that's useful to anyone, but I have admired how those look from the reverse side. Let's see. Any questions over in the chats? Yeah, Tyrone said that this tricolor one looks pretty good with gradients. So I created dithering patterns just using some pixel art software. I was using Sprite. Excuse me. So I used an 8 pattern dither gradient there to go from red to white in this case, or 4 dither pattern to go from black to red, and they look pretty neat. And you can get, as you can see, if you use certain, let me get a pointer here. If you use certain fairly uniform patterns, if you fill a screen with that, you get a sort of softer, lighter tone of red there. You can get kind of a pinky tone there if you fill an area with that. It doesn't look so much like a dither as it does a uniform color from a distance, which is neat. So yeah, what you display on it is up to you. You just have to conform to the standards of that display. Otherwise, it'll do it for you. Let's see, other questions. No, okay, good. All right. So that is going to do it, I think. Again, I want to say thank you so much for stopping by right before Halloween. These, let's take a look. We've got 49 of them in stock. You can pick up a display or more than one display if you want to pair it with this or swap out. If you take a look in the main product page here, I think we have a link to any of these raw displays. Let's see, are any of these? There's a nice quad color one. Well, I'll click on any of these and we'll get close. Then you can use the hierarchical links here, e-ink/paper. Scroll through these and then look for any of the raw displays. So here's quad color 3.52 inch 340 by 180 quad color e-ink paper bare display. Any of those that say bare display, we're gonna have that 24 pin connector on it. Here's the extension for it. So this little section of the site will help you out. Here's the 7.5 inch tricolor e-ink, which is basically the same as the one I demoed here. I think they may be identical. Someone had sent me this one, and it was made by another company. It wasn't the one that Adafruit sells, but it turned out to be the same chip, so it's probably the same factory. So you don't need these ones that come on a PCB. You can just use the bare displays. So there's a 4.2 inch monochrome or 4 gray, which is kind of nice. Monochrome or gray 2.6 inch, and so on. In the Learn Guide, there's a link to the 7-color display that I think Liz used. You can check that out. I actually bought a 7.5 inch 7-color display. Turns out it did not have a compatible connector, and I didn't realize that, so I couldn't demo that today. KBS asks in the chat, is there a link to the display being used in the live stream as well? So yeah, the two that I used are this one here, 7.5 inch, copy copy a link to that. Tricolor. And the other one is the 3.7. Let's see if we just see it through scrolling. Otherwise, I'll type that in. Yeah, let me just type that in. 3.7 inch. And it's that one there. Once you get to one of these bare displays on Adafruit, there's you don't have to click all around. Actually, there's the set of all of them listed here on the side. So these are all the ones that should work with this display here, or will work with this display. Or rather, will work with this feather. There we go. Using my words. All right. Let's see if there's any other questions. Otherwise, I'll wrap that up. I think that is it. David WA90NY says, will the display wear out? Yeah, and that's, I think, mostly with the number of refreshes. I'm not sure what these are rated for, but if you click on the data sheet for one of these, let's click on the one that I'm using here, it may say the number of refreshes it can handle, but it also is important to not refresh too quickly. So while you can circumvent some of those refresh time mandates, you will reduce the useful cycle of it. So yeah, I would say just look through here, and there should be in the data sheet for any of these display info about the number of refreshes that it should be able to handle in its lifetime. So good question. All right, if there are no other questions, we can get out of here and go cook a turkey. So that right there is my product pick of the week this week. It is the Adafruit RP2040 Feather ThinkInk 24-pin connector for e-paper displays and Stemma QT. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. Thanks everyone so much, and have a happy Thanksgiving if you celebrate. Bye-bye.